In this video, we are going to be looking at the binomial theorem. Or the binomial distribution rather. The binomial distribution has the formula. This is the formula for the binomial distribution. Now, in this formula, we are going to be looking at the parameters given in this formula. Now, PR means the probability. Are we getting it now? So, this PR here means the probability of getting an event X. And this NX here means what? N combination X. That is the meaning of this, N combination X. Then P is the probability of the event happening, and Q is the probability of the event not happening. So if we say N combination S, what does it mean? It means what? N factorial all over N minus 1 or N minus X rather factorial, then what? X factorial. That is what this N combination X mean. Now we said our N is what? The number of trial, or the number of trial, or in some question it is equal to the sample space. It's equal to the sample space. Now our X is the event itself. Then our P is the probability of the event happening. So we use P of what? Event happening. And then our Q is probability of event not what? Not happening. Are you getting it? Q is probability of the event not happening. Now, for probability, our P plus Q is always equals to 1. So in most cases, you may be given P, but you are asked to find Q. What do you do in that case? Our Q will be equals to 1 minus P. Now, when we take questions, you will appreciate this better. Let's take the first question here. The first question here say 12% of items sold up, 12% of items produced by a machine are defective. What is the probability that out of a random sample of 20 items produced by a machine, 5% are defective? Now, the random sample, the sample given to you, I told you that our N is our sample space. So, how many samples were given to us? 20 what? Items, which is 20. Are we getting it now? Now, our 12% is the probability that the items are what? Defective. That is, there are chances that out of everyone, 12% of them are what? Defective. Do you get it now? I will say that our P is the probability that the event will happen. 12 what? Percent. Now 12% is the same thing as to fraction become 12 over 100, and this gives us 0.12. Now the next thing we need to find is our Q. We said Q is equals to what? 1 minus what? P. That's our Q. Q is equals to 1 minus P. Now, if Q is equals to 1 minus P, it means Q will be what? 1 minus, what is our P? 0.12, and this will give us 0.88. Now, what is our X? Our X is the probability we asked to find. Find the probability that 5% will be what? Will be defective. 5%. So, our X is 5. Now, bringing out our formula. The formula says that our P of X is equal to N combination X, then P raised to the power of S, Q raised to the power of what? N minus X. Substituting into this equation, what are we going to have? What is our N? What is our N? Our N in this case is what? Is 20. So we have 20 combination. What is our X? 5. Then P is what? 0.12 raised to the power of 5. Then Q is what? 0.88 raised to the power of what? 20, which is our N minus 5. And this will become 20 combination 5 bracket 0.12 raised to the power of 5 bracket 0.88 raised to the power of 15. And when you punch this in your calculator, what are you going to have? you're going to have this as equal to 0.0546. To confirm, can check it from our calculator. That is 20 shift combination 5 times 0.12 then raised to the power of 5 times 0.88 raised to the power of 15. That gave us that answer. Okay, 0.0567 rather, not that. So the correct answer is 0.0567. And that is the answer to this question. Now let's take the next question. The next question says, injection of a certain dose of digitalis per unit of a body weight into a large number of frogs caused the death of 35% of them. Now I believe this is your assignment. Now it causes the death of 35% of them. What is the expected number of deaths when this dose is injected into each dose of 10 frog? What is the probability that the death will be? Now our n, they told you each dose of how many? The sample space given to you is what? 10. Now what is our p, the probability that it will happen? They told you that whenever something is injected, 35% of them die. So the probability that it will happen is what? 35%. Now 35% is what? To fraction becomes 35 over what? 100 proper fraction, and then to decimal becomes 0.35. Now what is our q? Probability that none, they will not die, it will be what? 1 minus what? P, and that is equal to 1 minus 0.35, and that is equal to 0.65. Are you getting this now? Now the next thing that we need to look for is, they told you that what is the expected number of deaths when this dose is injected into each dose of 10 frog. Now the expected number of deaths is 35% of 10 frogs, because they told you 35% of them will die. So the expected number of deaths is 35% of the 10 frog. 35% we said is 35 over what? Over 100 times how many frog? 10 frog. 10 cancel and 0 cancel 0. We are left with 35 divided by 10. 35 divided by this is 3.5. So 3.5 of them are expected to what? Die if you inject them into what? 10 frog. Are we getting it now? The next thing will be, next question is, what is the probability that the death will be exactly 3? Now probability that the death will be exactly 3, it means our x is equal to what? 3. And if our x is equal to 3, now we know the formula for normal the binomial distribution. Let's write it out again. It's px is equal to n combination x, p raised to the power of s, q raised to the power of n minus s. Now we already brought out our parameters. Our n is what? N is 10. Our p is 0.35. Our q is 0.65. Now in this case exactly 3, it means our s, the event happening, is what? Equal to 3. Now substituting into the equation, p of exactly 3 will be equal to 10 combination 3 bracket 0.35 raised to the power of so this is 0.35 raised to the power of, what is our x? Our x is what? 3 times, then we have 0.65, which is our q, raised to the power of what? 10 minus 3. Now this becomes what? 10 combination 3 bracket 0.35 raised to the power of what? 3 times what? 0.65 raised to the power of 10 minus 3 is what? 7. Now when you punch this in your calculator, it's going to give us, when you punch this in your calculator, it's going to give us this. Let me punch. This becomes 10 combination 3 times 0.35 raised to the power of 3 times 0.65 raised to the power of 7, and that gives us 0.2522. So our answer to this question is equals to 0.2522. That's the probability that exactly 3 will die. Now the next question is the probability that at most 5 will die. Let's solve that. The probability that at most 5 will die. Now the probability that at most 5 will die, which we can write as P at most 5, it will be equal to, what do we do? Is the probability that none will die plus the probability that 1 will die plus the probability that 2 will die plus the probability that 3 will die plus the probability that 4 will die, and then sum the probability that 5 will die. So this is the probability that at most 5 will die. Now let's take the first one, the probability that none will die. That will be what? N combination x. That's our formula. P raised to the power of s, q raised to the power of what? N minus s. Now substituting in, our n is 10 combination 3. Our p is 0.35, which is raised to the power of our x in this case is what? 0. Then times 0.65 raised to the power of 10 minus 0. And this will give us 10 combination 3 times 0.35 raised to the power of 0 times what? 0.65 raised to the power of what? Raised to the power of 10, because 10 minus 0 is 10. And when you compute this, it's going to give us 0.00604. So that's the probability that none will die. Now the next one, we are going to do those ones quickly. Probability that 1 will die, it means we are going just to change what? Our x. So this becomes, sorry, this is supposed to be 10 combination 0, not 10 combination 3, 10 combination 0. So this becomes what? 10 combination 1 times what? 0.35 raised to the power of 1 bracket 0.65 raised to the power of 10 minus 1. Of course, we know that 10 minus 1 is what? Is 9. So we erase this and put 9 here, okay? So we erase that and put 9 here. So at the end of the day, when you press this in your calculator, it's going to give us 0.07249. The next is the probability that 2 will die. So all we just need to be changing is our s, which is 10 combination 2. Then we have 0.35 raised to the power of what? 2 bracket 0.65 raised to the power of what? 10 minus 2. And of course we know 10 minus 2 is what? Is 8. So we can erase this, and in place of 10 minus 2 we put what? 8. So this will be raised to the power of 8. And when you compute this, it's going to give us 0.17565. The next one is the probability that 3 will die, and that is what? 10 combination 3, 0.35 raised to the power of 3, then 0.65 raised to the power of 10 minus 3. We all know that 10 minus 3 is what? Is 7. So if 10 minus 3 is 7, it means we can erase this and put what? And put 7 here. So this becomes raised to the power of 7. And when you compute this in your calculator, it's going to give us 0.2522, which we've solved before. The next one is probability that 4 will die, which is what? 10 combination 4 bracket 0.35 raised to the power of 4 bracket 0.65 raised to the power of 10 minus 4. Now 10 minus 4 is what? Is 6. So we can erase this and put here what? 6. And then when we compute this, it's going to give us 0.23766. And then finally, P combination probability that 5 will die will be 10 combination 5 times 0.35 raised to the power of 5 bracket 0.65 raised to the power of 10 minus 5. We said 10 minus 5 is what? 5. So we can erase this and here put 5. And then when you solve this, it's going to give us, let me use a different pen to write it so it will be visible. This will give us 0.1535. Now, have we gotten this? The next thing that we are going to do now is probability that at most 5 will die. What you do now is this 5 here. Now what you do now is to sum everything together, everything that you've gotten here. So this is probability that one will die, that none will die rather, to start with, is what? 0.00604. Probability that one will die, 0.07249. Probability that 2 will die, 0.17565. Probability that 3 will die, 0.2522. Probability that 4 will die, 0.23766. Probability that 5 will die, which is 0.1535. Let me rewrite this again to be visible. .1535. And when you sum this together, what is it going to give to us finally? Our final answer is 0.85, or sorry, 0.898976, and that is the probability that at most 5 will die. The next one is the probability that at least 6 will die. Now when you say at least 6, it means 6 and above. Is that so? So the probability that at least 6 will die, let's take it at least 6. When you say at least 6, it means 6 what and above. So this will be the probability that 6 will die, plus the probability that 7 will die, plus the probability that 8 will die, plus the probability that 9 will die, and finally plus the probability that what? Okay, let me erase this. Finally plus the probability that what? The 10 completely will die. So let's take the first one. The first one is probability that 6 will die. So of course we know our formula. Let me rewrite the formula again. The formula says P of x is equal to what? N combination x, P raised to the power of s, Q raised to the power of n minus x. So in this case, for P of 6, substituting in, we know that our n is equal to what? 10. Our P is 0.35. And our Q is 0.65. Now, substituting for p is equals to 6, it means our s is equals to what? 6. And this becomes 10 combination 6, then 0.35 raised to the power of 6 times what? 0.65 raised to the power of what? 10 minus 6. Of course, we know that 10 minus 6 is what? It's 4. 10 minus 6 is 4. And if 10 minus 6 is 4, it means we can replace here with 4. And when we do this, this is going to give us, and when you compute this in your calculator, it's going to give us 0.0689. Now, when we are solving things like this, there are we can easily come across errors. So please make sure you cross-check them to make sure that your answer is what is correct. Now, this is P of 7, probability that 7 will die. Of course, we know it's 10 combination 7 times what? 0.35 raised to the power of 7 bracket 0.65 raised to the power of what? 10 minus 7. Of course, we know that 10 minus 7 is what? Is 3. So we can change this to 3. This is raised to the power of 3. And when you compute this in your calculator, it's going to give us 0.0212. The next one is P of 8, probability that 8 will die. It's 10 combination 8. Of course, we know that this times what? 0.35 raised to the power of what? 8 bracket 0.65 raised to the power of 10 minus 8. And this, we know that 10 minus 8 will give us what? Will give us 2. So we change this to 2. And when we compute this, it's giving us 0.00428. The next one is the probability that 9 will die, and that is what? 10 combination 9 times what? 0.35 raised to the power of 9 times 0.65 raised to the power of 10 minus 9. Now, we know that 10 minus 9 is what? 1. So we can easily erase this, put what? 1 here. And this, when you compute this in your calculator, it's going to give us 0.000512. The next one, probability that 10 will die. Probability that 10 will die. That will be 10 combination 10 times, we have 0.35 raised to the power of what? 10. Then 0.65 raised to the power of 10 minus 10. 10 minus 10 is what? 0. So this computes to 0. And when you add everything here together, you're going to have us multiply. You're going to have 0.0000275. Now, what we are going to do now is to add everything here together. When you add everything here together, what are you going to have? You're going to have addition of everything here together. It gives us 0.0689 plus 0.0212 plus 0.00428 plus 0.000512 plus 0.0000275. When you sum everything here together, it's going to give us 0.0949, and that is our answer. Now you discover something, that the probability of 1 to 5, if you sum it to the probability of 6 to 10, it will give us 1 or something approximately 1. Now the probability from 0 to 5 is what? 0.8976. Probability from 6 to 7 or 6 to 10 rather, that we calculated is what? 0.0949. And when you compute this together, what will it give to us? To give us this 0.897 plus 0.0949. When you compute this, what is it going to give to us? It's going to give us 0.9919. 0.9919, which is what? Approximately 1. Are we getting it now? So you see that the probability that the event all will die is what? Equal to 1. Now, so that is that for this particular question. We have the last question that says we should compute the variance. We should compute the variance. Now let's take it. The variance for binomial distribution is NP what? Q, where n is the number of items. Here our n is what? 10. Our p is what? Is 0.35, and our q is what? 0.65. So computing the variance, our variance v, let me take it like that, becomes 10 times 0.35 times 0.65. So that becomes 10 times 0.35 times 0.65, and that will give us 2.27. So our variance is 2.275. So that is our variance, 2.275, and that is the solution to this question on digitalis injection of certain dose of digitalis per unit of a body weight into a large number of frog. Are you getting it now? So that is the solution to this question.